Science, speed and friction. Learning objectives. To recall the concept of describing the position, to explain the distance-time relationship, to draw distance-time graph, to discuss force and the force of friction, to list the effects of force, to understand the role friction in daily life. Topic list: Introduction, speed, distance-time graph, force and its effect, friction, examples of friction. Introduction. Position. While describing the position of an object, we measure it from a reference point. We need both distance and direction to describe the position of an object. The position of the bag shown above is described by using a coordinate plane. The values of x and y coordinates clearly describe the position of the bag with respect to the origin O. With respect to origin, the bag is at 3 units in x coordinate and 4 units in y coordinate, and hence we need to describe the distance as well as direction to describe the position. The position of an object may be different from different point of references. For example, the position of point A with respect to P is 5 units, whereas it is 3 units with respect to the point Q. The reference point, distance and direction are 3 important factors to describe the position of an object. The position of an object changes when distance, direction, or both change with respect to time. Consider the following 2 examples. An object moving in a circular path, a car moving in a straight. The distance of the car with respect to O remains the same, whereas direction changes continuously. The direction of the car with respect to A remains the same, whereas distance changes continuously. Speed. Speed of an object is the rate at which its position is changing in a given direction. While talking about the speed, we observe only the change in distance regardless of the direction. In example shown above, the car travels a distance of 15 kilometers in 15 minutes. Thus, we can find the rate at which distance of the car is changing with respect to the point O. Distance covered in 15 minutes is equal to 15 kilometers. Distance covered in 1 minute is equal to 15 by 15. Distance covered in 1 second is equal to 15 into 1000 divided by 15 into 60 meters. That is equal to 16.67 meters. Thus, car is moving with a speed of 16.67 meters per second. Thus, speed of an object can be calculated by dividing the distance travelled by an object by time taken in travelling that distance. Speed of an object is defined as the distance covered by the object in unit time. Speed is equal to distance divided by time, or S is equal to d by t. Instantaneous and average speed. Instantaneous speed of an object is defined as the speed of the object at a given instant. The speed of an object for a given journey may or may not remain same throughout the journey. When speed of the object is different for different distances, we find the average speed of the object. The average speed can be calculated by dividing the total distance covered by the object by total time taken. Average speed is equal to total distance divided by total time. S average is equal to d by t.